Hi, and welcome to the Pre-Algebra Tutor. Now, I know everyone watching this video is coming from a background where you know how to add, you know how to subtract, you know how to multiply and divide, you've had some exposure to fractions, you kind of have some idea about how to manipulate fractions and decimals and things like that in your basic math. And then you get into this topic of pre-algebra, and then after that, of course, you're going to go into Algebra 1 and Algebra 2 and all this other math that follows. And the tendency when you start a course titled Pre-Algebra is to maybe get a little frightened because the title of it sounds difficult. I mean, the word algebra, it just kind of has a natural ring to it of something that maybe is difficult. Well, I'm here to tell you that algebra, and of course the pre-algebra that we're going to do here in this course, it's not difficult at all. It really isn't. It's just a bunch of rules that you have to fully understand. And once you know those rules, doing the stuff is not really difficult at all. It's just like learning a language. There's lots of rules with language. How to make a sentence, how to speak, how to make verbs and nouns and all that stuff. And you know all this because you grew up and you learned how to speak by listening to other people. Well, in this course, the pre-algebra course, and all the other courses that follow, we're going to learn in exactly the same way. We're not going to learn with a bunch of boring lectures. We're going to learn by doing problems. So you're going to see a lot of problems. And I'm going to explain the topics, of course, but we're going to have a lot of problems up here that are going to show you how this works by examples. So you're going to see how it's done by basically doing it, by following along, and things like that. Now, what I'm going to encourage you to do for every section of this course is to watch the whole lesson through without pausing the video a whole lot of times. I don't want you to have a note sheet out trying to take notes. I don't want you to try to pause and work the problems in between me working the problems. I want you to watch and absorb, just like you do when you were 2 years old or 1 year old and just learning how to talk. You didn't have any note paper out then. You were just listening to everybody talk. Now, after you think you understand the topic, of course, you can watch the video again, you can pause and work out your problems then, of course, but I don't want you to do that the first way through. So what is this topic of pre-algebra anyway? I want to give you a little bit of motivation. You are about to embark on a really awesome journey because your basic math, your fractions and all that stuff, very, very important, absolutely essential to everything that we're doing in this course and all the other future courses. But really, algebra is when you first are able to get the tools to be able to solve more complicated problems. How did people invent the first airplane, or maybe invent the first spacecraft, or invent anything that could go into the robotics that can travel and go inside of a burning building and retrieve things, and anything like that in the modern world has all really been designed by scientists or engineers or mathematicians work on these things, and they all have to use math. And because of that, algebra is the very first stepping stone to being able to have those tools to do those things. And the reason it's so powerful really is because algebra and pre-algebra, they're all really about solving for things that you don't know. You always have a problem where you're trying to find the answer to some question, and so you set the problem up. You may not know what the answer to that question is in the beginning, but by solving the equation or setting up the equation that you're trying to use to solve the situation that you have, you'll find the answer. It's a really powerful tool. So we're going to start with baby steps. I'm not going to assume you have any idea what algebra is or what pre-algebra is, and we're going to take it one step at a time. Now, before we get into this section is titled Real Numbers, and we're going to talk about what a real number is and all that stuff. It's just basically learning some definitions of numbers. Unfortunately, you have to cover this in the beginning because every pre-algebra book is going to cover real numbers off in the very beginning, so I'm going to put this at the beginning as well. But before I kind of dive into the topic of this section, I want to just go ahead and say, pre-algebra has this reputation as being difficult, in my opinion, for two reasons. Students get put off for two reasons. One, it's because algebra or pre-algebra, it's all really the same thing. So if you hear me say the word algebra, I mean, we're learning algebra in this class. It's just the building foundation for what we're going to learn in algebra. The two things that trip students up and make them think this is difficult is the concept of a negative number. You really have never used a negative number before, really learning anything about algebra too much anyway. But negative numbers, and I'm just going to give you a quick little definition. A negative number is not a difficult thing to understand. Basically, if I tell you that you have positive 3 pencils, you have positive 3 pencils, how many pencils do you have? Well, you have 3 pencils. I mean, that's what it is. You have 3 pencils in your hand. We always use those numbers, but they're always positive. We always knew they were positive. We just didn't say the word. So if I have a positive 3 pencils, that's how many pencils I have, 3 of them. Now, if I say that instead of 3 pencils, I have negative 5 pencils, the negative is basically telling me that I don't really have any pencils at all. In fact, I actually owe you 5 pencils. That's what that really means. So when you see negative numbers, I want you to think about it in terms of what it really is. It's not a magical thing that's this mystical number that suddenly has a negative sign in front and it's so difficult. It's just telling you that I don't really have that many objects. I actually owe you that many objects. So, and you think about it because that's exactly what it kind of makes sense. If I have negative of something, it means I don't really actually have it at all. In fact, I owe you that many of whatever it is we're talking about. So if I have negative 2 sticks of gum, I don't actually have any gum. I owe you 2 sticks of gum. That's what that means. So we're going to talk about negative numbers off in this course, a little bit later, actually during the whole entire course. But I want you to calm down a little bit and realize that it's not that difficult. It just means I owe you something. That's basically what a negative number is. The second thing that trips people up in algebra is the concept of a variable. You see X a lot, or A or B. You see that running around the textbooks a lot. And people open a book and they see a bunch of negative numbers and they see a bunch of letters, and it gets scary because you've never dealt with that stuff when you had your basic math. Well, anytime you see a letter in algebra, try not to get upset, try not to get worried about it. What it really is it's telling you that you don't know what the value of that number is. So we may be trying to calculate something, but we don't know the answer yet. So we assign a letter to represent what we're trying to find. Like maybe we're trying to calculate the surface area of this sheet of paper. The surface area, how many square inches or how many square centimeters would fill up this sheet of paper. If we were to calculate the length and the width, we'd multiply them together and we would get the answer. But maybe we want to write it down, and represent the area as the letter A, because let's say we don't know what the area is. So we might put the letter A, and we might use that letter in an equation somewhere, because we need to know the area of the object to calculate something else. We might represent it with the letter A. And so that letter A just simply means, I don't know if it's 5 square inches of area or if it's 16 square millimeters of area. I don't know what it is. I just know that I have the area of something. So I'm going to use that variable is what we call it, the variable. So those are the 2 things that trip people up in algebra, and they're not difficult. Negative number just means I owe you something. I don't have that many, I owe you that many. And a variable is just a letter in algebra that we use because we don't know the value of whatever it is we're talking about. But we're going to calculate that in the end. And that's what solving equations is all about, trying to calculate the value for the unknown. That's what it is. So I wanted to get that out of the way because a lot of people get upset about that when they start to learn algebra and get worried about it. So we're going to cover all this stuff in great detail. I just wanted to give you a little bit of an advanced preview. Now getting to the topic here, we're going to learn about numbers, and so we're going to talk about real numbers. So let's just get right to it. A real number, these are all definitions that you'll see in your book. A real number. Whatever textbook you happen to be using, you'll always see a definition for a real number. My definitions are not exactly what you're going to see in the book. My definitions are more, layman's terms kind of definitions to kind of get the point across. But these are the definitions that make sense to me. It's any number that can be located on a number line. And we haven't even really talked about what a number line is yet. We're going to get into that very, very quickly. But basically, I'm going to give you one more sentence. I'm going to put it in parentheses here, and I'm going to put, it's every number or everything except imaginary numbers. Okay, So basically, there are these things called real numbers. Every number that you've ever used in your whole life has always been a real number. Every fraction, every decimal, here we're going to be talking about negative numbers, every negative number, every positive number, every repeating number, pi, any number you've ever used has always been a real number, because a real number is any number that can be located on a number line. And we're going to draw a lot of number lines in a minute to talk about that. The basic idea of a number line is, you know, you have something like this. This is a number line. It's basically a line, and you have 0 here in the middle, and here you have 1, 2, 3, 4 here. So these are the positive numbers going this way, and this arrow means these numbers go on and on forever, because you know numbers go on and on forever. And then here you have -1, -2, -3, -4, and of course -5, -6, -7, as you go on this way. So these are the numbers you've been dealing with all in your basic math, and of course we have these negative numbers because I have less than 0 pencils or whatever. I owe you some pencils over here. That's what the negatives mean. So any number that you can plot here is a real number. And so when I have here everything except imaginary numbers, basically an imaginary number, if you've been exposed to it before, great, you already know what it is. If you haven't, then don't worry too much about it, because it's not the purpose of this course to teach you what an imaginary number is. But a real number is every number you've ever used, you know, everything except for an imaginary number. So some examples of real numbers. The number 4, I mean, that's a number that you've used all your life. The number 6, the number 0, the number -3, the number 2.3, the number 2.6. I'm just making numbers up here. The number pi, which as you know is 3.14159, and it goes on and on forever. The number -1.66, and this little bar over the digit means that these digits repeat. So this is -1.6666666666, like that, on and on forever, etc. Okay? So any number at all that you've ever used in your life, you know, anything except the imaginary numbers, the so-called imaginary numbers, anything you can plot on this line. So I could find the number 4, put a dot there. I could find the number 6 over here. I could find the number 0. Pi is 3.14, so here's 3 and here's 4, so 3.14 would fall right in between there. -1.666 would be in between -1 and -2, etc. And we're going to do a lot of plotting with the number line here in a second, but I just want to tell you a real number is basically any number that you could plot. Decimal, fraction, because 1/2 is 0.5, you could plot that right there. So that is a real number. All right, now the next one is one that you probably haven't heard of too much until now. It's called an irrational number. Irrational number. Now what do you think of when you hear the word irrational? Irrational number. What do you think of? When I think somebody's irrational, I think that they're a little bit crazy, they're not really with us, they're really doing their own thing, they're kind of unpredictable. That's what irrational means, something that doesn't quite behave right. That's what irrational really is. So irrational numbers are numbers that really don't quite behave right. That's exactly what they are. So let's write the definition. They're numbers that cannot be written as a fraction. They cannot be written as a fraction. And let me go and write one thing in parentheses here. We'll change color to make it clear. And these are going to basically be non-repeating infinite decimals. All right, so some examples of an irrational number. It's better to sort of just show you by example what they are. Some examples of irrational numbers. They're very simple. They're things like pi. Because pi is equal to 3.14159, blah, 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 and it goes on and on forever. And these digits that come after pi, if you got a computer and you actually looked at the digits of pi out to 1,000 decimal places or 1,000,000 decimal places, you would find that these digits never repeat. They never follow any pattern. It's not like, you know, it'll say 15459, 15459, 15459. No, pi doesn't behave like that. It's a very special number. If you look at all the digits, they never actually ever repeat, ever. And believe me, people have been trying to calculate pi out to 1 billion decimal places to see if it ever does repeat, and it never does. So we say pi is irrational because it kind of goes on and on like this. There's no pattern to it. It's not repeatable, and you cannot write pi as a fraction. Some of you guys may think that, or may have heard, that you can write pi as a fraction. I think it's 22 over 7. That's not really true. That's an approximation. The number pi cannot be written as a fraction, and that's why it is irrational. Another number that just an example number that you cannot write as a fraction is the square root of 2. If you take the square root of 2, and we're going to talk a lot about these things a little bit later too. If you take the square root of 2, that's going to be something like 1.4142 ... If you don't quite know exactly what square roots are yet, we're going to get to this a little bit later, but this is a number. You can put it in your calculator and you press the square root button, and you're going to see a bunch of digits that go here, and if you calculate those digits on and on and on forever, you'll see there's no pattern, there's no repetition, and you definitely cannot write this as a fraction. The only way to get this number is by this. So you can see that my list is pretty short. There's lots of other irrational numbers, but they're not things that really we deal with every day. We see pi all the time, and that's why I put it first, because that's the one you actually know about. That's the one irrational number that most people have ever actually seen before. That's why they're called irrational, because you cannot write them as a fraction. They're non-repeating infinite decimals, and that's what we have here. So if we have irrational numbers that are little weird, wacky numbers that don't quite obey what we think is normal, then the next type of number you might guess would be the rational numbers. So let's go and take a look at that. So the rational numbers. All right. Now, what do you think of when someone is rational or something is rational? The word rational means they're well behaved. They obey the rules. They are things that have a nice nature to them, and they're very calm, cool, and collected, and they're rational. So these numbers should be numbers that are quote-unquote well-behaved type of numbers. And so that's exactly what they are. Rational numbers are numbers that can be written as a fraction. All right, so they can be written as a fraction if they're rational. And in fact, almost all numbers can be written as a fraction in one form or another. So most numbers are actually rational. So let's look at a couple of them. What about the number 0.5? Is this number rational? Well, it can be written as 1/2. So it is rational. You can write that as a fraction. The number 0.25, is that rational? Well, you can write that as 1/4. So it can be written as a fraction, so it's rational. What about the whole number 2? Well, you can write this as 2 over 1. So that is a rational number because it can be written as a fraction. What about the number -5? Well, you can write that as -5 divided by 1. 5 over 1. So it is rational. What about something a little bit weird like 0.6666, and then you put a little bar so the 6's go on forever? Well, it looks like that is irrational, but in fact this decimal can be written as 2/3. If you put 2/3 in your calculator, that's what's going to pop out. So that is rational. This is actually rational. What about the fraction 1/3? Well, of course, it's already a fraction, so it's rational. And what about the fraction -7/8? Well, it's already a fraction. It's a negative. Negative has nothing to do with it. If it can be written as a fraction. A negative fraction counts just as much as a positive fraction. So, of course, it's already in fractional form. So you see, pretty much any number that you could possibly think of can be written as a fraction. Even the weird decimals, even if they're infinite decimals, if there's any kind of pattern to it, like this one is a pattern because it's got 6's going on forever. But you have other decimals out there like, 0.154, 154, 154, 154, 154, on and on forever. That has a pattern to it. Anything like that that has a pattern, you will be able to write as a fraction. Now, I may not be able to tell you what that fraction is, but it is going to be able to be written as a fraction. It's only when the numbers are kind of going off squirrely with no pattern at all and there's very few of those that we really deal with every day. That's what we call irrational. Most numbers are actually rational, which is what we have here on the board. Okay? Now the next thing I want to talk about are what we call integers. Now, we are going to be talking about the word integers a lot. I mean, in fact, all of these numbers are important, but we're going to be using the word integer a lot. Don't let it scare you. Integer is positive, negative, or zero number with no decimal. Now, like I said, in your book, you're probably not going to see that definition. This is my definition, but your book will have something similar. So, for instance, you might have the number 0, 1, 2, 3, 4, 5, dot, 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 dot. In other words, 6, 7, 8, 9, 10, 11, 12, on and on to infinity. And then, of course, on the negative side, we've got negative 1, negative 2, negative 3, negative 4, negative 5, dot, 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 dot. So integers are really all of these numbers that don't have any decimal point. I mean, in other words, 4.5 is not an integer. 1.2 is not an integer. 0.3 is not an integer. Integers have to be these numbers that are these nice whole numbers. It can be negative, it can be positive, it can be zero. Those are called integers. And we'll just use this term a lot in algebra. You'll see it coming up. But that is my definition of what an integer is. I think it's a good one just to show you what they really are. There's nothing more to it than that. It's just basically the numbers, positive or negative, without any decimals. A whole number now, the next thing here, the next couple things we're going to talk about here, a whole number, you know, it's useful to know these only because they're in your book and because you're going to see them on a test, but really you're not really talking too much about whole numbers. I mean, you'll just see why in a second. A whole number are the positive integers, and you also include 0. So 1, 2, 3, 4, 5, dot, 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 dot. So when you say something is a whole number, it means the positive integers, and also you kind of include 0 in there. So it's just a definition. I mean, there's nothing special about whole numbers. It's just a label. Integers are the positive and the negative numbers without any decimals, and you also include 0. Whole numbers are the positive ones if you also include 0. And there's also another one that you will see in your book. Let me switch colors here. And those are the natural numbers. All right, the natural numbers. And those, actually, let me take this off like that. The natural numbers, just to show you by example, those are 1, 2, 3, 4, 5, 6, dot, 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 dot. So basically, these are the positive integers, and you don't include 0. That's the only difference between a whole number and a natural number. The reason they're called natural is because when you're a kid and you're counting jelly beans, if you have a physical object here in front of you, like this pencil or this marker. So I have one marker. And then if I have a pile of markers, I'll start counting them, 1, 2, 3, 4, 5. So those were considered natural because those are the numbers that you use to count things. Typically 0, even though it's definitely an important number, you're not counting objects with the number 0, because usually if you're counting something, you have more than 0. So that's why they call them natural. I guess what I'm trying to say is these two things down here, I mean, they're useful to know for your test, but you're really not going to use them too much in algebra. You're not going to be asked too much in the future. You know, hey, go ahead and list the whole numbers here, you know, in this problem. It's just not something you're really going to see, but it's a definition. Integers you will see a lot, and so that's super important. The main thing to take away from these boards here is that the world is divided into the real numbers are the general umbrella of all numbers that you could possibly plot on a number line. And those are divided up into the irrational, which are numbers that you cannot write as a fraction, and then also the rational numbers that you can write as a fraction. And then getting even more specific, the integers are the numbers here, like you see here, with positive or negative numbers without any decimals, and 0. Whole numbers are the positive numbers including 0, and natural numbers are the positive numbers when you don't include 0. I'm going to draw a little picture for you here in a second that's going to hopefully make that a little bit clear. Now, the next topic, or the next type of number, is something that's useful. Again, you'll see it on your test, you'll see it in your pre-algebra course, but I'm not going to sit here and lie to you. It's not something that you're going to use in every section coming up here in the rest of the algebra sections. But it's something that you probably have heard about, and it's called a prime number. And the only reason that books really even talk about prime numbers is because they're kind of special numbers. A prime number is a whole number other than 0. The little line through it means 0, so you don't confuse it with the letter O. 0 and 1. Other than the number 0 and 1, that is divisible by only the number 1 and itself. And every time you write the definition of a prime number, most people, their eyes cross and they just don't quite get it because it's kind of a complicating sounding thing. It's whole numbers other than 0 and 1 that is divisible by only 1 and itself. It just doesn't seem to make a lot of sense when you write it down, but you'll see why it's written this way. Let me give you an example of some prime numbers. The number 2 is a prime number. The reason it's prime is because the number 2 is only divisible by the number 1. When I say it's only divisible, I mean only divisible with no remainder. So you can only divide this number by the number 1, because 2 divided by 1 is going to give you 2, and you can divide it by the number 2, which is itself. 2 divided by 2 is 1. You can't divide it by anything else. 2 divided by 3 gives you a decimal, 2 divided by 10 gives you a decimal, 2 divided by 4 gives you something else. You can only divide it by the number 1 and the number 2, which is itself. That makes it a prime number. The number 3. You can only divide this number by, actually let me go across here. The number 3. You can only divide it by the number 1 and the number 3. You can't divide this number by 2 because that would be 3/2, that's a decimal. You can't divide it by the number 5 because if you do, you're going to get a decimal answer. When we say it's divisible by, we mean divisible where you don't have any decimal left over. So 3 can only be divided by 1 and itself. 5 can only be divided by 5 and 1. 7 can only be divided by 7 and 1. 11 can only be divided by 11 and 1. 13 can only be divided by 13 and 1. 17 can only be divided by 17 and 1. 19 can only be divided by 19 and 1. 23 can only be divided by 23 and 1. And you could go on, and you can get a computer to calculate all the prime numbers out as far as you want to go, and that's fine. People do that. But just know that it's sort of an infinite series of numbers that have these special properties. Now let's look at something that's not prime, just to kind of give you an example. 8, the number 8 is not prime. And the reason it's not prime is because, I'll just put because, B-E-C, you can divide it by 2 and you can divide it by 4. 8 divided by 2 gives you 4, and 8 divided by 4 gives you 2. So those are 2 additional things besides the number 1 and the number 8 you can divide into there. And so it's not prime. The number 10 is not prime because you can divide the number 10 by 2, and you can also divide it by the number 5 evenly. One more example. The number 12 is not prime because you can divide it by a whole lot of numbers. You can divide it by 2, you can divide it by 3, you can divide it by 4, and you can divide it by 6. So you see, the higher up you go in the numbers, you're usually going to be able to divide by lots of different numbers that will divide evenly. But every number in this list, the only numbers you can divide into there is the number 1 and itself, which itself is the number itself. Okay? Now also notice that prime numbers exclude 0 and 1 from being prime by definition. That's just the definition of the prime number. So that's what it is, ladies and gentlemen. Those are the types of numbers that we're going to learn in this section. Let me draw a quick graphic because I think it's going to make things a little bit clearer. And then after that, we will work, I guess, a couple of practice problems to kind of show us where we're going. So first, we have what we call the real numbers, right? Which is basically everything, everything except for the so-called imaginary numbers, which you typically don't learn in algebra, but just keep in the back of your mind that there's something called an imaginary number. You've never used it up until now. It's something that's kind of a little more of an advanced concept. But everything else left over is what we call real. That's why they're real. We can touch them. We can use them to count marbles, things like that. And a real number is basically everything. So that's the top level of the hierarchy. And coming out of the real numbers, you can kind of split this into the rational numbers. Right, the rational numbers, and of course, the irrational numbers. Right? Now, just to refresh your memory, something like an irrational number would be like the number, pi. 3.14159, dot, 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 dot. You cannot write this as a fraction. All of the rational numbers can be written as fraction. All of the irrational numbers are just these random decimals that go on and on forever, and you can't actually write them as a fraction. Let's change colors. Now, this path kind of ends right there. Now, the rational numbers can be broken down further. So the rational numbers, you have what we call the fractions, right? So that would be, just like you would think, 1/2, 2/3, -1/4, dot, dot, dot. Just any kind of fraction that you would think of is rational, because remember, rational numbers can be written as a fraction. So of course, the fractions are rational, right? And then you have decimals. Now, when I say decimals, these are decimals that have some kind of pattern to them. Even if they go off to infinity, they have some kind of pattern, or they just terminate. So something like 0.25, 0.333, bar on top. So 0.25 can be written as 1/4. 0.3333333 off to infinity, that can be written as 1/3. Any of these decimals that have any kind of infinite pattern or just a decimal that stops can be written as a fraction, so it's rational. And you also have what we call the integers. And those are things like -2, -1, 0, 1, 2, dot, 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 in both directions, right? So all the negative numbers there, all the positive numbers there that don't have any decimals, and also the number 0, those are integers, right? And any of these integers can be written as a fraction also, because the number 2 can be written as 2/1. The number -2 can be written as -2/1. So you see that the world really consists of these real numbers that are broken into two camps. The rational numbers can all be written as fractions, and they would consist of, the fractions, because they're already fractions, the decimals that can be written as fractions, and the integers that can all be written as fractions too. So pretty much every number you've ever used is over here somewhere, right? The only numbers that are a little weird are these things called irrational numbers, and there's not too many examples of them that you really are already familiar with, but just know that they're out there. Something like pi, you could probably go and calculate different irrational numbers without a problem, and those are numbers that just go on and on forever with no real pattern to them, and you cannot write them as a fraction. That's really the definition. Let's erase the board, and let's get some practice with identifying these different types of numbers. Okay, now what we're going to do now is write some numbers on the board. We're going to write them over here, and then we're going to go ahead and look and try to identify what type of numbers that they are, and put a little check mark in the different, in the different columns. And you'll find out that most numbers have check marks in different columns, more than one column, because you can see from our little hierarchy tree that we had over there, a number can be, can have different labels associated with it. So let's go ahead and do that. Let's start with the first number. The first number was, let's say, the number 30. And let's just go right across the top and see if that is there. So it's a real number because, as we said before, pretty much any number that we have that doesn't have an I in there for imaginary is always going to be real. Rational. Is it rational? Can it be written as a fraction? Well, of course it can, because 30 divided by 1, 30/1, is possible. Is it irrational? No, it's not irrational, because it's not an infinite decimal that goes on and on forever. Is it a whole number? Yes, it is, because a whole number, remember, are the numbers that are 0, 1, 2, 3, 4, 5, 6, and they go on like that, including 0. Okay, is it an integer? Well, yes, it is an integer, because remember, integers are all the negative numbers, all the positive numbers without any decimal, and including 0. So that is an integer. Is it a prime number? Well, it is not a prime number because I can divide 30 by the number 10, I can divide it by the number 15, I can divide it by lots of different numbers and still have an even division. So this number is real, rational, whole, integer. And we could even have more columns with natural number and all this other stuff. If they're just labels, I'm just trying to give you a little bit of practice here. All right, what about the number 0? Well, 0 is a real number. Just like we said, pretty much any number is real unless it has an imaginary thing attached to it. It's rational because you can write it as a fraction. The number 0 divided by 5, 0 over 5 is going to be equal to 0. 0 over 10 is going to be equal to 0. So you can write it as a fraction, so it's rational. It's not irrational. Basically, a number cannot be rational and irrational at the same time. Either you can write it as a fraction or you can't. That's what that boils down to. It is a whole number because whole numbers are the numbers 0, 1, 2, 3, 4, 5, and on up. It is an integer because integers include 0. And prime number is excluded from being 0 or 1. And we talked about that when we talked about prime numbers. All the prime numbers, they don't count 0 and 1. They go up from there. The next one I want to talk about, 0.50. Is it real? Of course it's real. Pretty much all these are going to be real. Is it rational? Can it be written as a fraction? Well, yes, because we can write it as 1/2. It's not irrational because it's going to be one or the other. You can't, you can write it as a fraction, so that's not going to be there. Is it a whole number? Well, no, it's not a whole number because whole numbers are 0, 1, 2, 3, 4, 5, etc. Integers are all the positive and negative guys, but they have to have no decimals, so it's not an integer. Is it a prime number? Well, it's not a prime number either because those are whole numbers as well that are divisible by itself and the number 1. So the number 0.5 is only real and rational. Okay, the next, let's talk about something a little different, -3/8. So we have a fraction here, -3/8. It's a real number. Is it rational? Well, yes it is because it can be written as a fraction. It already is a fraction. It's not irrational for the same reason. It's not a whole number because those are, 0, 1, 2, 3, 4, 5, whatever. It's not an integer. It's not prime because all of these are basically numbers like 0, 1, 2, 3, 4, 5. They can't have fractionals or decimals involved. So this is just real and rational. Okay, let's look at the number 1. It's real. It's not imaginary, so it has to be real. It's rational because you can write the number 1 as 1 over 1. It's not irrational for the same reason. It is a whole number because whole numbers are 0, 1, 2, 3, 4, 5, 6, 7 on up. It is an integer because those are the positive and the negative numbers with no decimals, so that fits into that category. It is not prime though because prime numbers from our definition we just had on the other board cannot include 0 and 1, so it's not prime. All right, now let's look at the number pi. Is it a real number? Yes, it is real because there's nothing imaginary about the number pi. There's no I there. Is it rational? No, it's not because you cannot write the number pi as a fraction. Is it irrational? Yes, it is, our first irrational number. Is it a whole number? Well, no, it's not because it's got a decimal involved. Is it an integer? No, because it's got a decimal involved. Is it a prime number? No, because it's got a decimal involved. Those last 3 columns are only going to apply to numbers that don't have any decimal. So that's basically it. Pi is real and irrational. Let's look at the number 2.12, just the decimal, 2.12. Is it real? Well, yeah, it's real. It doesn't have any imaginary parts to it. Is it rational? And I'm going to tell you, yes, it is rational. You can write it as a fraction. And you may not know right away if these decimals are written as fractions, but the way that you really look at it is, if you have a number that has a decimal that just stops eventually, like after 2 or 3 decimal places or whatever, you can always write it as a fraction. I mean, in this case, for instance, this guy, 2.12, you can write it as 212 divided by 100, or 212 over 100. Because if you put this in your calculator, it's going to move the decimal point 2 points back, and it's going to give you what you're looking for. If you dump this in your calculator, you'll find that it equals this. So you can write it as a fraction, but you're not always going to be able to think of the fraction that you can write it as, but you know that if it stops, or if it has a repeating pattern of any kind, like 2.105, 105, 105, 105, any kind of repeating pattern, you will be able to write it as a fraction. All right, so it's real and it's rational. It's not irrational because we can write it as a fraction, and none of these apply because we don't have any kind of we have a decimal point involved. What about the number 1.11, and we'll put a bar over the 1, so what this means is it's 1.11111111111 on out to infinity. It's real because there's no imaginary number involved, and I'm telling you based on our definition that it is rational because there's a pattern here. It does go on forever, but the pattern is that it's all ones. So there is a fraction that would equal that. Now I don't know what it is, but it's just sort of a mathematical truth that it's going to be that way. It's not irrational because you can write it as a fraction. It's not any of these whole number, integer, or anything else because there's a decimal involved. What about negative 2.5? Well, yeah, it's real. It doesn't matter if it's negative or not. It's a real number. It doesn't have any I or imaginary part to it. It is rational. Just like I said, the decimal point stops. Now, in this particular case, I know how to write that as a fraction. You can write that as negative 5/2. If you put 5 and divide it by 2 in your calculator, negative sign out front, you'll get negative 2.5. Okay? But as I said, you don't need to know the fraction that's equal to. You just need to know sort of the rule. And none of these other things apply because there's a decimal involved. Now what about negative square root of 2? If you get the square root button on your calculator and put 2 in there and hit the square root, stick a negative out front, it's real. I mean, it doesn't have any imaginary parts to it. It is not rational though, because if you look at it, the numbers that you'll see in your calculator, even if you get a computer, you'll find that there's never any pattern. So there's no way to write that as a fraction, and so it's irrational. And it's definitely not a whole number or an integer or a prime number because there's decimals involved there. And what about the number 5? Well, it's real. It is rational because we can write it as 5 over 1. It's not irrational for the same reason. It is a whole number because we can, whole numbers are 0, 1, 2, 3, 4, 5, and on and on. It is an integer for the same reason because those are positive and negative numbers with no decimals. It is a prime number also because the number 5 can only be divided by the number 1 and the number 5 itself. It can't be divided by anything else, and if you try to divide it by anything else, you're going to get a decimal. So that's basically it. You see, these numbers can have multiple labels. They can have multiple labels. And that's because there's overlap. The integers have overlap with the whole numbers. I mean, the integer is more broad there. And of course, every prime number is also going to be an integer, and etc. You'll just sort of see that. The only thing that is sort of going to be one or the other is going to be rational versus irrational. Either you can write it as a fraction or you can't. So that concludes this section. I know it probably wasn't the most thrilling section just to learn about numbers and how to classify them, but every book starts with this material just because everyone has to know the definitions. Math is just like a foreign language. You have to know the definitions. If you do, then when someone says irrational number, you won't worry about it. You'll understand what they're talking about, and so you'll do well. If you don't know what an irrational number is or a prime number, then when you see that on your test, you're going to get stressed out, upset, worried, and then you're not going to do well because you're worried about it. So make sure you understand this material. It's important for the sections that follow. We're going to take you baby steps, one step at a time through this class, so that by the end of it, coming in here, you have no idea what algebra is about. Coming out the other end, you're going to have a fair amount of really good pre-algebra skills under your belt, ready to tackle Algebra 1 and do really well in those courses. I'm Jason. I hope you've enjoyed the lesson. Let's go on into the next one and continue on through the course.